Hello, Achu. This question says assertion potential difference across the terminals of a battery is always less than that of EMF of the battery. Reason: during discharging of a battery, potential difference across two terminals of a battery is V equals to E minus IR, where V is less than E. And here assertion is true, reason is true. Reason is a correct explanation of assertion. Option B, assertion is true, reason is true. Reason is not a correct explanation for assertion. Option C, assertion is true, reason is false. And option D, assertion is false, but reason is true. First of all, we need to know the key concept. Okay, की कॉन्सेप्ट में मेनली हमको दो टर्मिनोलॉजी अच्छे से जानना होगा, दैट इज टर्मिनल वोल्टेज एंड ईएमएफ. तो terminal voltage is the potential difference across the terminals when the switch is on. Okay, and another terminology, that is EMF or electromotive force, and this can be defined as the maximum potential difference generated by a cell when there is no current flow in that circuit. Okay, now after discussing these two terms, we also need to know about discharging and charging of a battery. So first of all, let's know about discharging. Okay, suppose that we have this circuit. This is the cell. Cell का जो EMF है, that is capital E. Okay, then we have this internal resistance small r, and we have the load resistance, that is capital R, right? और इस डायरेक्शन में करंट फ्लो हो रहा है. So in this case we can write that I equals to capital E by capital R plus small r. Okay, because we can see that the internal resistance and the load resistance, both of them are in series. तो सीरीज केस के लिए जो इक्विवेलेंट रेजिस्टेंस होता है, दैट इज द एडिशन ऑफ द रेजिस्टेंसेस. ओके, फॉर्मिंग द सीरीज कॉम्बिनेशन. तो नेक्स्ट लाइन में हम लिख सकते हैं कि E इक्वल्स टू I इंटू कैपिटल R प्लस स्मॉलर. The next line again we write I into capital R plus I into smaller. I into capital R. So this is the potential drop across the load resistance, which is represented by P plus IR. So in case of discharging, we can write that P equals to E minus IR, that is terminal voltage equals to EMF minus potential drop due to the internal resistance. Okay, and next we discuss about charging of the cell. Now again draw a diagram. This is the cell with EMF capital E and internal resistance small r. Okay, now चार्जिंग के केस में क्या होता है कि जो लोड रेजिस्टेंस रहते हैं that is replaced by an external source of voltage or potential. Okay, so suppose this capital V is the external source and current is flowing in this direction. Okay, and in case of charging, current flows from anode to cathode, and we can write that I equals to V minus E by small r. So V is the terminal voltage in this case, which is also the external voltage. और चार्जिंग में के केस में क्या हो रहा है कि सेल के जो EMF और इलेक्ट्रोमोटिव फोर्स होता है that is less than the terminal voltage applied, that is less than the external source voltage. Okay, in the next line we can write that V minus E equals to I into small r and V equals to I into small r plus E. So this is the condition for charging. Okay, so let's go back to the first slide and read the assertion, which says potential difference across the terminals of the battery is always less than EMF of the battery. Now this statement is false because चार्जिंग और डिस्चार्जिंग दोनों के केस में अगर हम देखें तो अगर हम I equals to 0 कर दे तो at most we get V equals to E. Okay, when I equals to 0. लेकिन assertion में हमको कह रहा है कि potential difference across the terminals of a battery is always less than the EMF of the battery, which is wrong. So assertion is wrong. Now let's check the reason here. Reason में हमको कहा गया है कि during discharging of a battery, potential difference across two terminals of a battery is V equals to E minus IR. We can see that in case of discharging, this is the condition we have direct. Okay, that is capital V equals to E minus IR, where V is less than E. So we can now say that reason is true. डिस्चार्जिंग के केस में जो वोल्टेज का सप्लाई है that comes from battery. Okay, तो बैटरी का जो voltage है that decreases, and we can say that in this case EMF is greater than the terminal voltage. Okay, so from our conclusion we can say that assertion is false but reason is true. That is option D is correct. Hope you have understood it well and best of luck.